Good evening and welcome to tonight's webinar. My name is Katalin Dumitrash and I'm the Principal Cloud Architect here at Pentalog. Tonight, we're going to be talking about how to take your Python microservices to the next level by using a service mesh and AWS. Let me start by sharing my screen so you can see the nice, pretty graphic presentation that I have prepared for you. So, one quick second. Alrighty. And there we go. All right, can you see the screen? Please let me know in the chat so I know it's safe to move on. All right, thank you. So you started your microservices journey. You currently have hundreds of microservices. This is not uncommon. Well, not everything is roses, of course. You are now in a state where you have discovered that managing the communication between your microservices and, of course, figuring out which microservices is causing you troubles is no easy task. If your, let's say, catalog service is failing, if you're an e-commerce store, chances are it's not the catalog web service that is actually failing. Chances are it's probably something related to the pricing microservice. And the pricing microservice is usually dependent on, let's say, an ERP system, not necessarily an ERP microservice, just a service that exposes data from ERP. So congratulations, you have achieved a distributed monolith. Now, obviously, we've chosen microservices because they resolve some of our biggest complaints with monoliths. But like with everything in life, there is no free lunch. You solve 80% of old issues and you get some new ones as a gift. So obviously, we're in the same boat together. This is not a new issue, and most of us are tackling as microservices get more and more traction. So let's take a look at tonight on how we can make our lives easier. We're going to be covering why we should be using cloud, why AWS. We're going to be briefly glancing over infrastructure as code, and then moving on to the good stuff, serverless Docker cluster, what serverless containers really are, an application load balancer, adding a service mesh, setting up a service discovery. All in all, what is this observability and how do we achieve it? We're going to go through a demo tonight. And of course, it wouldn't be a webinar without a Q&A. So let's start. Why the cloud? For previous webinar viewers, I apologize. I'm going to try and make this short, but it is something that is important enough that we go over because there are always new people joining in this series. So why do we choose a cloud today? Because it allows us to deliver more, faster, and to focus on what matters. It is pretty clear that we, as programmers or engineers or architects, whatever your role is, our job is to deliver features and to help our users in whatever manner we choose to do so. And maybe focusing on how our network attached storage array works is not the best use of our time. Figuring out how to deliver a new important complex feature probably is. And how does the cloud do this? Well, first, it abstracts. It abstracts from me for all of those, let's say, as I said, network attached storage, how actually a data center works, all this multiple power thing, multiple internet connections. Why do we need to know about these things? Why do we need to know about how a load balancer that's hardware-based works or not? We just want to include it and have it work in our application, right, in our environments. And the stuff that the cloud doesn't abstract away, it offers the API for us to automate. Think about all those menial tasks, the stuff that you hate to do over and over again, day after day, month after month. We just want to make our lives easier and focus on what matters. And that's why we should use the cloud today. brief overview about where we were and where we are today, starting from on-premise situations and maybe have a data center that's already bought by a company, all the way to, let's say, a serverless scenario or something like that. So when you go into the cloud provider scenario, you have something called an infrastructure as a service. You no longer have to manage the storage, the hardware, the networking aspect of things. And as a benefit, you don't have to call somebody to add another server in your rack. You just do an API call or push a button. Moving forward to that, we have platform as a service, or it's more or less the same with container as a service, where the database and the operating system gets abstracted away and we just play with the runtime, i.e. our language of choice and our application. And the base situation to be usually is a serverless situation where you just supply the code and the cloud provider does all the rest, right? This usually goes hand in hand with using a lot of managed services, so you wouldn't implement that AI all from scratch. You'd be using an imaging service that tells you if there are cats in the picture or anything of that sort. All right, so if you're looking for a cloud provider, why should you choose AWS? Well, that's a question everybody's asking. So Amazon Web Services has been the leader in cloud providers for God knows how many years. I believe that the Gartner Infrastructure as a Service Magic Quadrant shows AWS being the leader for the 9th year in a row. So definitely an industry recognition over there. We have a pace of innovation that's unmatched. In 2018, they have released almost 2,000 features. They're very much looking forward to reinvent this year to find out how much they managed to do this year. So besides all of that, what's most interesting is that the community built around AWS. You have the biggest amount of users for any cloud. You have a ton of books, video courses, help forums. So basically, talent is easier to find. And if you're Googling or using Stack Overflow, you're bound to find an answer to your question if it's not one of the newer services. Good. Now let's look at infrastructure as code. You wouldn't want to be in almost 2020, now currently 2019, probably if you're watching this as a recording, and still provision everything by hand or even as a CLI script. So the better way to do it today is by using infrastructure as code. I won't bore you by getting back to the past 10 years, how it all started, what the options were. I'm just going to give you the best option today to save you some time right now and in the future. So first, what's infrastructure as code? Infrastructure as code is the idea that we treat our underlying systems and devices the same way as we treat our software. That is, we describe our infrastructure, let's say how many servers, databases do you want, as code, and we version it in our Git, and we use the same flows. We use peer reviews, merging, all of that to be able to deploy and manage our infrastructure, which does add a lot of advantages because you can always revert back to a known state. And it's very easy to automate spinning up new environments when you so need to. There's the idea that you really don't want to have your infrastructure, your environments as really, really precious things that you don't want to touch because you're afraid you'll break them. All right, so the best option today is actually treating it as code in a programming language. Past tense, we usually got templating languages, which was all right, but obviously a programming language, a real programming language is much, much better. So I present you the Cloud Development Kit in just a few words. This was recently released into production by AWS, and it basically allows you to use a number of programming languages such as TypeScript, JavaScript, Java, C, Python to create your infrastructure. It extends on the idea of pre-processing templates like before, so pre-processing YAML templates, and it adds a real programming language on top with a few interesting features. So if you take these two concepts, pre-processing templates and a real programming language, you get the CDK. CDK in the background actually compiles down to the same CloudFormation scripts, which are YAML-based as before, but this is abstracted away and we really do not care. We do get the advantages of using a real programming language and the stability of the existing solution, which is based on CloudFormation, which is great for us. How does this look? Well, if you ever tried anything with previous infrastructure as code providers, let's say SAM or serverless framework, or maybe Terraform, you probably had quite a few lines to add a serverless Lambda function. Well, how does this look today? A single line, albeit a bit passing by the code standards, more than 100 and something characters, but you can now create a Lambda function in the cloud with one line. How cool is that? So the nice demo, as you might have guessed it, is done in CDK. And to give you a bit more context, there are 3 levels of constructs in CDK that we need to watch out for. So constructs that we call level 1, this is a one-to-one automatic generation from the API on which CloudFormation is based. Construct level 2 is an opinionated version from AWS, which is written by their engineers. And what's nice about that is they provide you with really good, solid standards and best practices, good starting out points for security, scalability, and so on. And the level 3, which we're going to be showing after today as well, is your own components. So since this is a real programming language, you can abstract away some of that complexity and reuse your own code very, very easily. In fact, we're going to show you how easy it is to add a lot of complex features by basically instantiating one class. All right, there we go. We got rid of that tooltip over there. So before we dive into specifics, let's take a brief overview about how our demo tonight, what the architecture will look like once it's complete. I do believe, yes, I did move the tooltip. Thank you very much, Sherban. So we're gonna have a single region infrastructure or architecture, if you will, using 2 availability zones because we want to be highly available. An availability zone is basically a grouping of data centers in a close enough distance that AWS considers as a single unit. These are completely isolated. One availability zone is completely isolated than another availability zone in terms of power, internet connections, anything like that. All right, so we're gonna have a high availability scenario. We're gonna have NAT gateway, which just provides networking. It hides, we use public subnets and private subnets because public subnets are basically something that you can reach from the internet, and we wanna hide all our microservices so they are secure in a private network, which doesn't have that capability. Also, NAT gateways, what they allow you to do is they allow your private subnets to talk with the internet in case you want to install something or use a third party. All right, you can now see over here on the right 2 services that we're going to be discussing about at length tonight, CloudWatch and XRay. So I'm just going to hold off explaining those for a second. If you look here, you're going to see a bunch of, let's say, serverless containers here that we have called greeter, greeting, and name. And we're going to see another container over here called Envoy, and we're going to be discussing about that shortly as well. We have an ECR, which is basically our private Docker repositories. Obviously, I do believe that most of us using microservices architecture today are using some sort of containering. So like usually Docker, but there's also other options available out there. In the middle, you'll see something very interesting because our clients, our users send us the information, their request. Let's go with the option of it being HTTP-based request. And it goes into an application load balancer. Now, this is like a normal load balancer, but with greater feature sets. And we're going to be talking about that shortly. And this load balancer takes us into our auto-scaling group because we have nice containers, will be nice to scale on demand. And all of our microservices are communicating through this service mesh. In AWS, this service is called app mesh, and it would be nice if they would be able to discover each other. Otherwise, it would be making for a really poor demo tonight. So that's why CloudMap is over there. Now, keep in mind all these services. Generally, you don't have to remember their name. I'm always going to be reminding you what they do because there's so many terms in these services. It's a full-time job keeping up with them. Let's move on. All right, so let's talk about a serverless Docker cluster. And the first thing we have to do for a serverless Docker cluster, of course, is to create our Docker cluster. Now, there are multiple options in AWS. As with any cloud provider, you got Kubernetes as a service, you got build your own, and you got the native server. This service that we're going to be talking about tonight is ECS, Elastic Container Service. And that is a pretty good option in my opinion, because if there were to be a choice, I would usually start off with serverless. So for any new project I'm building an architecture on, I usually consider serverless as a first option, because as you saw from a previous slide, you basically have a very small footprint that you have to manage, and you leave the rest to the cloud provider. Of course, you have to be knowledgeable with some new techniques and some tools, but it does offer a lot of benefits for that. But if serverless, for example, is not an option, what would be my second choice? Obviously, containers, maybe serverless containers. That would be the best choice. And I would go with ECS because unlike with EKS, which is the Elastic Kubernetes service, you don't have to manage a lot of things. Of course, the Elastic Kubernetes service saves you the trouble from managing your main Docker server, but all those other workers you still have to manage by yourself, which is a pain. Again, still much better than building everything by yourselves. I hope that by the end of this year, nobody will actually be managing Kubernetes by themselves in a cloud. Of course, on premises, you don't have any other choices, but in the cloud, you should really leave this to a cloud provider and free up some time to do all the interesting things that are in your backlog. So how does ECS work? Well, you got that container registry, which is your private Docker repository that basically hosts all of your containers. And ECS, based on whatever you define, will take your containers and deploy them, either on EC2 instances or on Fargate, which is a platform from AWS that we're going to show in the next slide. And ECS does all the work around it, managing your containers, figuring out where to put what, when, which is really powerful. But if you're using EC2, there's, like in the Kubernetes example, you're still having to manage some instances, and that's not really what we want. We want to focus on what we have to do for our users. So we want to look into Fargate. What does Fargate do? Oh. All right, I believe I missed the Fargate slide. So Fargate basically abstracts away your Docker cluster. You no longer have to manage any instance. You just have to tell your cloud provider, in this case, AWS with ECS, that you would like that your container have that amount of CPU and that amount of RAM. Of course, auto-scaling is still achievable. It's actually even simpler because you no longer have to scale your EC2 instances and your Docker services. So you just say, I want this RAM, this amount of power, just run my services. You could open one container instance, or you can open 1,000 or more at a time. There's nothing for you to manage. You just say how many of them you want, which is pretty powerful. Now, I mentioned infrastructure as code. How would this look at an infrastructure as code application, right? So this is a TypeScript demo that we're going to be looking at tonight, and this is the snippets of the actual code that you're going to see in the demo. So we instantiate the VPC, which is basically a namespace in the cloud, your virtual private cloud. It's a way to put things into containers if you want. And we're going to give it a name of meeting VPC and a max availability zones of 2 in one line of code. And then we just create our ECS cluster as it is. Right? Pretty simple. All right. There we go. There's my Fargate slide. So that's a serverless container. You just give it your container, you tell it how to run, and Fargate takes care of everything for you. And you might see that this might take a lot of code or time or anything to implement. Not so much. I mean, obviously there's a few lines of code here, but it's not as much as the effort you'd have to put in another situation. So we have the concept of tasks inside your service. So these are mappings of your containers. And you can see here that I'm defining an app container that's going to accept a port number to forward, and I'm defining my service over here. And I simply say that I want 2 instances of that service running. Pretty easy if you ask me. All right. Keep in mind, this is abstracting a bit for presentation purposes, but once we get to the demo part, you'll see the full code end to end, right? All of the resources creating, all of the components getting together, and you'll also see all the benefits and how it works in the cloud. All right, moving on to our application load balancer. Well, why do we call it an application load balancer? Because it really is more powerful than a normal load balancer. So an application load balancer works on the layer 7 of the TCP stack instead of the layer 4. And what that means is that on layer 4, you only have information available like IP addresses and port numbers to base your routing decisions on. When you have a load balancer, you have much more flexibility. And let's look at what that means. For any load balancer that's an application type, you have listener rules. And these listeners basically represent port. If you're going to be serving traffic on HTTP or HTTPS or other ports, you basically have to have a listener for each of these ports. In a microservices architecture, you probably want some service to respond for your front page, some service to respond to the checkout, service another for the pricing, you know, all of the discounts. Basically everything is more or less another service. And of course you could build yet another abstraction service that's going to be your front service or whatever, your gateway, but why do that if you don't have to? So all of these targets in here basically represent containers in our example for your service, for your microservice, sorry. And a target group is basically a logical group, your actual microservice. So for example, your users microservice are going to have 2 targets, 2 containers, and it's going to be a target group called users. And what's important about that, because you use a rule to define the path, for example, of the requests that you are receiving, and you forward them to the necessary target group. And it's pretty powerful. I mean, you got support for cookie routing, domain name routing, basically whatever is in the request, you can probably route on. And some additional features that may be interesting for you. You got HTTPS support out of the box, so you don't have to mess around with HTTPS on your containers. You support server name indication for hosting multiple websites, let's say, with different domains and HTTPS. You can use all kinds of things as a target for your groups. I mean, you could even combine it with Lambda to make a hybrid serverless approach if you just need something quickly. And of course, it comes out of the box as being a highly available service. It supports WebSockets, and it has health checks. Those health checks are really good when it comes down to finding out how your application is handling load, because you can see a pattern over time, and you can make all kind of nice dashboards for almost no money in CloudWatch. A bit of a spoiler alert there. So let's see how we can add an application load balancer. Well, as with the rest of the code samples, this doesn't seem to be a lot of work, because we just instantiate the application load balancer class. We tell it that's going to be an external facing load balancer. We could also have private load balancers, which are not accessible from the internet. And we are the listener. In our case, we're just going to keep it simple, add an HTTP listener. Of course, for the target groups that I mentioned earlier, there's going to be some different work required, but that you'll see in the demo. All right, let's add a service mesh. But let's take a look at what is a service mesh first, right? This is a very, very nice definition from Envoy Proxy, an open source software that is also being used inside AWS as a managed offering, as a basis for the managed offering called App Mesh. And basically what they say is it's really, really a different scale of problem that you have to handle in relation to network and figuring out what's happening in your system when you have a lot of microservices. And I really agree with that statement. So networking and observability, I would probably say communications and observability. So a service mesh is basically a software layer that handles the communication between your services. And it also has some nice extra features that basically prevent you from having to implement all of those common things, common features that you might need to gain communication and visibility or observability, as we're now calling it, into your application. So instead of implementing, I don't know, distributed tracing all around your microservices, you just use a service mesh and it comes by default. That means you don't have to change all your microservices as they are today. Quite a nice feature. All right, let's take a look at some use cases, because service meshes, while they're beautiful, they're not for everybody. You should probably not be using service meshes if you don't have a large number of microservices now or plan to have it in the near future. You could use a service mesh if you need to control the traffic, right? If you're looking to add a retry mechanism to certain queries, if you want to change routes on the fly without doing code changes or deploying services. You could do A/B testing, which might sound weird. Why would you want to do A/B testing on your services? But it makes a lot of sense when you talk about this in a canary deployment, because you want to scale that traffic incrementally to find out if your new and improved microservice can do as good of a job as the old one. What happens if you have microservices in more than one platform? If you have Kubernetes, EC2, ECS, maybe some other stuff on premise. I'm not sure if on-premise is supported, so don't quote me on that, but all of these options here on the slide are, it's a much trickier thing to manage than everything in a single platform. And usually things are not simple. So that can be a valid use case. And also, if you have no idea what's really going on, it takes you a lot of time to debug stuff. Obviously, I don't recommend you refactor everything and include a bunch of new code to add visibility, because that would take forever. It would be nice, but it would take forever, and it's not a valid approach. So service mesh can help you get a lot more visibility since it's baked in by default. All right, let's take a look at App Mesh. So App Mesh is the service mesh offered by AWS today. And this graphic over here shows you a before and after with App Mesh. So you got service A trying to call service B and service C, and service C is not responding. And the example with App Mesh, you can have a logic that says if service C is not responding, you can go to another place, right? So traffic is dynamically rerouted to a healthy service instance. And while that may be a valid use case, I'm mostly interested in the traffic weighting scenario, where you can say that I want 20% or 50%, let's say, going to this service, and then another 50% of the traffic going to that other service. Really lowers the worrying when you can do migrations from one service to the other. Much more easier to experiment than go full and switch it in a day and see what happens. So Some components of that mesh. I must warn you, this is maybe not the best terminology in the world. And service mesh is a relatively new technology, and its terminology might use some way. So we have that service mesh, which have been talking about. We have virtual services, which are basically an abstraction of our real service. And then we have virtual nodes. Nodes can point to a target group or something of that sort, or basic implementation of our actual targets, our machines that are, or containers that are going to be doing the work. And we have Envoy proxy. So the Envoy proxy works as a sidecar. It basically goes along like you're sticking on a sticker to something. And the way actually a service mesh works is by intercepting or handling all the traffic coming in and out of your microservice. And your microservice doesn't need to change because it thinks it gets the traffic from whatever it received it previously. But in fact, it gets all its traffic through the Envoy proxy. And Envoy is the actual thing that gives you all this visibility and flexibility. Right. Then we have the virtual routers, which basically handle processing the routes to decide where to go, to what virtual node to take our traffic in. And for virtual routes, you can have, as I said, multiple rules as to what to put them, how to handle the traffic. Okay. Again, as with our previous example, adding a service mesh initially is not a lot of work. You just have to have a few lines of code. Feel free to ask some Q&As in the Q&A section of the webinar. Even if I don't answer right now, I'll answer in the Q&A section, or right after, if there are a lot of questions, right after this webinar, we'll answer them via email or an article in the blog. All right. Service meshes are a bit more complicated than that, but it will just be a lot of slides, and I might as well just show you the whole demo once we get to that point. All right. It's a wonderful thing that we have a service mesh, but we would need to actually discover things inside our service mesh. Otherwise, it wouldn't be much of a purpose, would it? So let's talk about service discovery. Previously, we had DNS discovery in AWS provided by the DNS service there. It is something that is being used on a lower level over here as well, but CloudMap is really something that has upped the game in terms of service discovery, especially in serverless scenarios where you don't have IP addresses. Everything is distributed. You just have a pointer to your function or your database table. You don't have an IP address where you can actually ping. So CloudMap is extending the idea of DNS discovery by providing sort of like a registry that you can sometimes query by DNS, but sometimes you can query also by APIs. And that's pretty powerful. And we can see how it works over here. You have a front-end service that's basically going to a number of back-end services, version 1 and version 2. And you have to do a code change to basically point it from one DNS to another DNS pointer. With CloudMap, you'd basically move this all into a configuration state. And you would be just changing something in the CloudMap registry and say that, hey, for all of these entries, stop going to version 1, go to version 2. And that also is very nice because it requires no code changes at all. So I have not shown you how to add CloudMap in CDK because it's really very, very little work. It's just a few lines, and it's also integrated with the ECS cluster. So there's a few lines spread out over multiple areas. That's because AWS has abstracted away a lot of the complexity that would normally take you to provision this in CloudFormation or Terraform for that matter. By the way, if you're a Terraform fan and want to use something like infrastructure as code, but you don't want to go into, let's say, CloudFormation, maybe because you have a multi-cloud scenario, not a big fan of that scenario, but it can happen from time to time, check out Pulumi. It is sort of like in the same manner, but for for Terraform. If your major investment is in AWS, I highly advise you to remain in the ecosystem because you're going to get a much better experience. But if you are in a multi-cloud scenario, check them out. It is well worth it. All right, so let's talk a bit about observability. It's a really nice buzzword. And if you Google it, you're going to find a nice academic description that comes from control theory, which is really not the best way to explain it to people. So observability, as I said before, is having things set up in a way that you can understand what's going on in your system, especially when something isn't working, without having to add a bunch of code and deploy it with debug calls, printing to special logs and whatnot. So there's a lot of tools which are cool, really, really cool today. I actually got this definition from a really popular tool that's high quality in my opinion, Honeycomb, that says observability is that capability of you answering what's happening inside your system just by observing the outside without having to ship new code, which is awesome. It's one of the most clear explanations I have found. However, with these nice new fancy tools, sometimes the price tag is pretty big. And especially for you out there working in a greenfield scenario, maybe working on a proof of concept, it is highly unlikely that you will be able to get a stakeholder to approve, I don't know, $100, $200 offering if you're looking to integrate that into your new microservices. And there's also a disadvantage that it makes me want to not go into all of these offerings, is that they require special attention and work, and you cannot add them in your infrastructure as code most of the time because they don't really have an API like AWS. So you have to manage them manually. And if there's one thing I don't want to do in today's environment is put myself in a disadvantage where I have to manage everything manually, because my competitors, I'm talking as a client, my competitors are probably not doing that, and they're moving fast, and moving fast sometimes means a lot to a business. So let's talk about the first service that can help you achieve observability, because you achieve observability by understanding what's going on inside your system. So you need high quality, so you need a large amount of good logs, metrics, not just from infrastructure, but also from your containers in this case. And you need to centralize them in a place where you can easily process them. CloudWatch is such a place. And by default, it collects all the metrics and logs from your AWS services. And it can be configured, well, actually, if you're using ECS, everything you output for a Docker container goes inside CloudWatch. So it allows you to monitor everything. It even allows you to do nice, really, dashboards like this. Granted, they're not the prettiest thing in the world, but they're so cheap. Nobody will ever notice you using them. If you're on a small project, you won't even pay for them because it's in a free tier. And it really does help you a lot when you build this from the grounds up in your development environment and it goes all the way to production. You can play with them, interact with them, learn them while you're creating the application, and use the same skills in production with the same tools because it comes already provisioned, right? You do all of these, this work once using an infrastructure as code tool, and you deploy it, and you get the rewards from using this every day. So you build really nice dashboards. You can also build the alarms that notify you when something's going on. You define what you want to do. You can even use machine learning to spot anomalies in your metrics. So that's also very easy to do. It's 2 buttons to click. It's not a lot of cost, but obviously I wouldn't use it for everything. All right, you have logs, but how do you look for them? Being able to explore your logs was usually the unique ability of the Elk stack, Elasticstash, Kibana, Logstash. No longer the case. So with the launch of Log Insights, which is a managed, available right now in your AWS account offering, which you can take your CloudWatch logs and basically play with them as you'd wish. No more working to feed stuff to your Elasticsearch cluster. no more managing that cluster, no more paying for those instances. So this scales with you. It starts when you're really small. You don't have to configure anything. It's there, right? As long as you have data inside CloudWatch, and you can see it's pretty fast. I'm saying 2 seconds and something for scanning 50 something megabytes of data, right? And this is data that is stored pretty compactly, I would say. So that's not that bad. You can use SQL queries, well, sort of like SQL queries. You can build some visualizations. Again, it's not the most pretty thing in the world, but it gets the job done. And for having it there at the start of your project, that's pretty powerful. And again, you'll have it in every environment that you build, not just production, because with higher cost services, yeah. I want to talk to you about Container Insights. So Container Insights is one of the wonderful things that AWS has offered us, which add a lot of value, and it's very easy for us to enable. You just go, do 2 clicks. There's going to be a blog article that's going to refer to this technique, but you can just search Container Insights. There's a document page on how to set it up. It's basically going in and activating it, and it has a lot of good dashboards for your microservices, regardless if they're ECS or Kubernetes based. And by Kubernetes, I mean the managed offering, not build your own and manage it. That's, of course, not supported out of the box. And now we're actually going to be looking at it tonight, and it's going to be pretty sweet to see a bunch of stuff going on over here. And keep in mind, I did not have to build any of these dashboards. I just enabled them. I don't have to build or specify anything. It came out of the box. And it's something that pretty much every project needs. All right, so we have logs, metrics centralized, and we can view them. But how can we actually figure out what's happening inside the services? I mentioned an example where you have a service that's failing that you think is the root cause, but in fact, there's like a service really far away that's actually providing you with that error. It's just a lot less noisy, and it's getting overrun by your catalog service or whatever service that you might be having in the front to your customers. So this is where distributed tracing comes to mind. Distributed tracing is quite a new thing. It is something that's gaining a lot of traction now with the microservices community, and it's something that can definitely help you out. Here we have XRay, which is the AWS version of distributed tracing. And it's not just for your microservices. The advantage of using XRay in your environments is that it's also integrated quite good inside your other AWS services. So for example, if you're using serverless, if you're using a load balancer maybe, or if you're using any of the other sorts of, well, actually load balancer, sorry, I misspoke. Load balancer is not supported out of the box. But if you're using something like Beanstalk, ECS, if you're using a service mesh, these are things that are already integrated. And we're going to be looking at this example tonight. And we didn't have to set up anything special for our microservices to enable XRay. We just had to say that we want to have XRay on. So when you use fancy tools like this for distributed tracing, you'll see that it's quite easy to pinpoint root causes of issues. I mean, you might have a service like over here that's giving you errors, these two that are in front of your clients, but maybe the actual issue is over here, more in the middle. And again, the issue from the middle is probably up here on the right, which is your DynamoDB table being under provision, right? So that causes your services to fail for the upstream. It's really hard to get a clear picture of that when you have an issue in production and you have tens or hundreds of microservices. So this is where distributed tracing does help. And it's not just a pretty picture. I'll show you what XRay can also do for you over here. So it has a lot of capabilities to analyze those traces that you receive. And traces are not just limited to outside of your application or services. It can also help you inside your services. For most of the popular languages out there, there are official AWS SDKs for XRay. And for other languages that are also quite popular, like PHP. They are community ones. AWS has not yet released those. But what's important is that you can add annotations inside your code, define segments that you would like to treat like logical blocks to figure out if there's any slowdown or differences in how it runs for a customer or particular scenario. So here we have, this is taken from an AWS blog article, which is really nice. I recommend it. It's going to show you immediately if you go and search for XRay Analytics, I believe. And it's going to show you how to drill down an issue that's being actually experienced by one customer, in this case, Emma. Because you can see you can filter out certain things and compare basically like one group with the other. And because we have annotations in this example, we can actually know what logged in user is performing certain calls. Obviously, take care if you have GDPR concerns or HIPAA compliance concerns for medical applications. Maybe you will want to have your actual username, maybe something like a unique identifier. And you can pretty easily see that you have some traces over here for Emma, which have basically a large amount of failures, let's say. And she's experienced a lot of the issues described in that blog article. And if we drill down into those traces even further, we can see this is, of course, Python microservice over here, that in API call to generate the ACL, we're spending a lot of time, right? 300 milliseconds off of a total of 322. And this is basically a service that's talking to a database, a NoSQL database called DynamoDB, and also calling an Elastic Beanstalk application to get some data. So obviously, 300 milliseconds just for generating the ACL is quite a lot. And this is one way to find out that you can optimize your application and just pre-compute your ACL and store it in DynamoDB or a caching like Redis, Elasticache, Redis, or Elasticache Memcache. So Redis is highly available. That might be a better choice in highly available situations. So distributed tracing is not just for the outside of the application or services, it's also for inside them, right? The best way I can describe this is if you know New Relic, Datadog, or any of these tools, they more or less have an agent sitting inside your infrastructure and sending out those data to the servers. In AWS, this is a bit more easy because they come more or less out of the box included with certain scenarios. In other scenarios, we have to include them as a sidecar. So that is another container attached to your container. We're actually going to be looking at XRay tonight as well. I do not know what this is looking this way. I'm sorry about that, but the demo tonight is based on code in a GitHub repository called Greeter App done by Nathan Peck. Nathan Peck is actually a developer evangelist or advocate at AWS and does a lot of containers. I also recommend his other wonderful GitHub repository called AWS Resources, which will set you on the right track if you decide to put your next project on ECS. So, demo time, quite exciting. Let me just quickly glance over in here inside my IDE. I'm going to enter presentation mode, but before I do that, I'd like to show you the structure of this project. This is a CDK project, and disregard this. I believe I did not add the required package in this copy of the demo. And you'll see that we have a bin repository. This is our entry point into our cloud infrastructure. And we have a library folder over here and a services folder. In the library, we have our stacks and our constructs. This is a top level construct that we built and reused. And these are all our microservices. So since this is a talk about a webinar about Python microservices, I should probably show you the microservices because in Nathan's original example, it came as being a Node.js app, and I couldn't leave them like that. I had to turn them into Python. So let's start with the greeter service. You can see that we have a Docker file, we have a requirements file for our libraries, and a service file. Let me quickly open the service file and go into presentation mode. All right. So we're using Flask. Why not? It's easy, and we just wanted to do something fast that works. We're using Flask. We're using requests to do our communication between our microservices, and our greeter is our wonderful entry point service. Let's say that this is where the requests come from the application load balancer. And you can see that we get our two environment variables, which is the greeting and the name URL. This allows even further flexibility. If you want to change it in the future, we only have to change it in this repository, not the actual code itself. Always a good practice. There is a few exceptions. And for our hello route, we have basically done two calls to our other microservices, and we output this information over here by using the host name, the greeting, and the name. And before we go further, it would be nice to show you that this actually works right now. So you can see over here that we have hello from the internal domain name of our front service, let's say the greeter. For our front service, we have an IP address, and then we have a hello. If we refresh, we're going to go to hey, hi, hello. And then we have a name over here that's also changing, Larry, Thomas, Lisa, and so on. And of course, we have the IP address of the last microservice over here, which is totally different. And we know that it's not a single application. So moving back, how does this look? View projects. I have to exit presentation mode for a second. How does our requirements file look? That's pretty easy. We just have Flask and requests over here. And for a Docker file, oops, sorry about that. For a Docker file, we have a pretty simple Docker file that basically starts from Alpine because we want to have it really, really fast for building. We make an app directory, we copy our source code over there, and we install our requirements. Curl is added as a package because we need it when we do our health checks. So friendly tip over there. If you're using Alpine and you previously used Debian-based stuff, you're not going to get curl or anything like that out of the box because obviously it doesn't have a lot of packages. So that's why certain things might fail. That took me a bit of time to figure out. So as an entry point, we just say that we want to run service.py, and that's it. Let's look at the other microservices because we have a greeting service, of course, that follows in the same way. We have a Docker file, which is exactly the same. We have a requirements file, which is exactly the same. And we have a service that basically does a random choice between a number of greetings over here. So not a lot of things to say. I'm going to also zoom in for you guys over here, make sure that's clearly available for you to see. Not a lot of logic over here. But when it comes to the name microservice, it is slightly more complicated. Well, slightly. So same thing, we just have another requirement over here, and the requirement is Faker. Faker is a really nice library that we can use to generate our fake data for our tests. And that's what we did over here. We basically said that we would like to generate some first names because we don't want to hard code them into our code. And there's already a library there. So that works pretty well. These are free microservices for tonight. There are relatively not a lot of logic, not a lot of complexity into them. So let's look like how did we implement this whole thing. So we imported our stack because we are using infrastructure as code, and we are able to abstract and use the same principles as with any programming language. We can use classes, we can you build stuff that we can reuse. And this is what we did. We basically said, hey, this is our new app. We're going to build a new stack. And if you guys want to do another stack, we would basically just duplicate that line and give it another ID and another name, of course, and we would be on our way to create a second infrastructure, and it's that quickly. That's the power of infrastructure as code. So let's not talk too much about this. Let's go into a demo stack. Let's see how it really looks. We import our libraries. These are constructs level 2 directly from AWS. I haven't built them myself. I just use them. It's really just like a normal library that we pull off of npm or composer or pip or anything like that. So we will create a demo stack that says we want a VPC. Remember the presentation, and we want to create an ECS cluster. And that wonderful ECS cluster, we would like to have some DNS with some service discovery, not necessarily just DNS, but let's go with DNS as a version. It's only going to be available internally. That's one of the advantages of CloudMap, right? It's as with all other AWS services, it's tightly integrated into their security offering with identity access management. So when we say we just want these services to have access to it, that's what it will do. So we added some service discovery over there. We created a nice little app mesh, and of course our roles, because we want to have some access to XRay, ECR as a container service, and for CloudWatch. In a real life scenario, please drill down and be more specific about the types of permissions you're giving to your services. This is a bit too loose, but for the purposes of this demo, it will suffice. So let us configure a health check for all our services. And I would say that a health check, since we're using port 3000, a health check every 5 seconds. That comes after 10 seconds. After we start our containers, and the timeout of 2 seconds with a maximum of 3 retries before we consider this container to be good or bad, especially when it doesn't work. It's pretty much good for our use case. It's a decent health check, and again, not a lot of things to discuss over here. So the most interesting part is this new service. A class called service does not exist in the framework we're using today. We created it ourselves, and we're giving the cluster, the mesh, the port number, and some application container values. So right now, we're not using a CI/CD pipeline. We're building the containers locally, and well, actually, we're not really building them. The framework is building it for us. We're just supplying the folder where the assets are, and we supply that we want to have logging done with AWS CloudWatch. This is done over here. Pretty much, we see that we instantiate one service, 2 services, second service, and third service, and all basically we have our environment over here that we specify our URLs for the other microservices. Keep in mind we're using the internal domain name, the greeting.internal that we specify over here. Where are you? Name internal. Let me just, yeah. Name internal. And after we add all these 3 services, we do some magic. Well, magic, what I say is that it's a custom defined function that connects our greeter service to the name service and our greeter service to the greeting service. So again, we've used code to abstract away the complexity of connecting the dots between our service mesh, and all we have to do is like call that function. We then add a load balancer and that listener, and we say that all the traffic that's coming in through the load balancer should go to our greeter service. Pretty nice. And of course, we want to know what the URL is for our new microservice-based application. And I would just like to go through the service class, because this is where a lot of the functionality really is, right? So I mentioned about XRay Envoy being as attached as sidecars to your application. And this is actually where you see that implemented. You see that we are using a repo from AWS App Mesh Envoy, and we're pulling in this repository on this Docker container, and we're using it. We're actually defining this this container over here. We're saying that we want to ignore this traffic, and this is the application ports, and we give it the roles that it's supposed to work with. And then we add some dependencies on our real microservice, because it should depend on the Envoy, but also on the tracing, distributed tracing container over here, which we will define further down. So this is how it actually looks when you add your real service. And again, this is a fair amount of lines of code, and that's why we wrap it in a separate class. We just reuse it. Right, what's notable about this? You can see that I just specified the memory limit. I don't specify a set of machines it has to run on. It's out of the box. And yep. Oh, when I define the service, I add a few CloudMap parameters, which is again something required for our DNS discovery. And our virtual node, for, as we stated, for an app mesh, for service mesh, we need this virtual node, and we have to do a bunch of settings over here. I'm not going to go through every one of this. Is really not that necessary, especially when you have examples out there on the internet and you don't have to focus a lot on the actual implementation. So you can see that we instantiate all of these app mesh. We make it work with our other components over here. And these are the functions that we are interested in, right? This is what makes our reusability really cool, because we say that we want to connect this port number with the 3000 port, which is actually in our application, in our microservice. And we add that in the service, we allow it to communicate there, and we add that backup, the backend over here. So again, really, really nice stuff. All we had to do is use the code, and we didn't really have to do a bunch of extra stuff. So this is how it looks. Let's see how well it runs. Right. So first, let's make a few requests, right? I'm not sure if you can hear me, but I'm F5ing over here. If you want to also look at it yourself, let me put this in Zoom. I'll put it in the chat if this works. I really want to put it in the chat. Let me, all right, to everybody. Everybody. There we go. If anybody wants to generate more traffic with me, be my guest, right? Let's add some load in here so we can play around with the stats, all the metrics and stuff. So we've generated some traffic, right? This is the actual CloudFormation stack that was generated by the code I showed you. It has quite a few resources over here. These are the resources. And we didn't have to generate them by hand, which is nice. And we have our output, which is the URL you are accessing. Okay, so that's enough about CloudWatch. Let's look at how it really is in ACS. No, actually, let's look at the CloudWatch console for container insights before it goes. Since we generated a bit of load, we've been looking at, let's say, 1 hour as an interval, and now looking at the ECS cluster over here. You see there's only one ECS cluster, and the average CPU load is just 11%. And the memory is not far either. We have a constant free number of free services over here. And we have, let's say, a little bit of CPU over here usage. It always takes about a minute to everything to show up over here. Let me just also refresh it in a second. Yes, so we see a bunch of loading here that goes up and down from memory as well. And we can play around with 3 hours, 1 hour, and all of that stuff. This is per cluster, right? If we want to go further down, and we can go per task or per service. Let's go per service first. All right, so now you can see that we have free services, and I believe that we have generated some load on the greeter service. Well, the greeter service is doing some random stuff there to select from our greeting array, and that means it's doing a bit more work than the others. That's interesting. The memory utilization is pretty constant, and so is the number of tasks and deployments. Pretty nice. Now, let's drill down a bit into our actual tasks. So again, we can see that per task, we have a higher CPU average done by the greeter task, and we have some storage, read and write. That's nice. It's actually quite nice. So again, this comes for like basically no work at all. You have this in your CloudWatch window over here, done by default, but maybe you need a little bit than your metrics. Let's look at some logs, right? So usually when you look at logs, they come like this. You go into something like over here, and you just see a bunch of JSON with some errors maybe, and you have some limited filtering capability. But when you go into log insights, well, then the situation is a bit different. Let me select something from over here. Let's go back to ECS clusters, and over here, let's select something really interesting. Let's say that we want greeting, right? And we want to put more greeting task. There we go. Why don't I just select them? If you go for the previous console, it automatically selects whatever service you want to look at. There we go. I just selected a whole bunch of them. Let's run some queries of it, right? So obviously, we can see that there's a fair amount of queries. I'm scanning over 100 megabytes of data here. It took just 8 seconds. And we can see that we have a bit more logging going on over here, since we're basically, since we're generating the traffic. We just generated the traffic a few minutes ago, and we can further drill down into this specific area. And you might be asking what's generating all of this? Well, all of the stuff we have configured so far, it's made to generate a lot of logs. We can adjust that, of course. So let's go into visualization. Oh, I would be able to add some visualizations over here. I can even do some sample queries. We have some common fields over here that they discovered, like ingestion time, log stream, the message, timestamp. It's more or less like other solutions, but it's there by default, which is really, really powerful. Let's take a look in distributed tracing, XRay, right? Because we played around it, we talked about it, and we want to see it working for ourselves. So as you can see, we have quite a few things going on. We do have a little bit of an error over here in the app. This is the greeter over here. So this is actual, you'll see the nodes for the service mesh and the services over here. And you have the option of going straight into analyzing some traces. And you have the same window over here, and you have, don't have annotations set up, but you can see there was a 404 at a certain time. And if we want to see what's going on with this 404, well, There we go. It seems that the trace URL over here is saying that this browser has said that it wanted a favicon.eco, a favicon, and we don't have that set up in our microservice, so that's why we generated a 404. That was pretty easy to figure out. Of course, you can play around with response times, types of traces, URLs, of course. So there's a lot of value in this. And annotations are very, very powerful. And you might say, how much does this cost? Well, look at the official page. But what I can say off the top right now is that 100,000 traces each month are free. And if you want to configure the sampling, you can configure it over here and basically say sample 10% of my traffic. Don't save traces for everything I do. Very, very cool in production because it allows you to have the same capabilities without a lot of cost. And let's just look at how cheap XRay pricing is. Because I said it was cheap, I might as well show you. So first 100,000 traces recorded are free. And for Paris, for example, you get $5 per 1 million traces. And again, it's up to you how much you want to record out of that based on your traffic. I say that's not a lot of money considering what you can actually do. All right, so we went through our XRay. Is there anything else we should do? I should actually show you ECS over here. So ECS, really wonderful. You have those free services over here. If you go into any of these services, you have settings for the DNS discovery. They also be able to see it as a separate service called CloudMap. You have all the events that's ever happened for this service. Like you see me here doing a deployment yesterday, and it has replaced tasks. Now you can have metrics specifically from this dashboard if you wanna. You don't have to go all the way to CloudWatch. These are the same metrics, and you can also access the logs. And you can access the logs per each container. You see the two sidecars over here, and we have, yay, we have traffic. Awesome. Cool. So that concludes our demo this evening. Let's go back to our very nice presentation over here. And as you can see, let me just try and clear this up. There we go. We had our demo, and now it's time for the Q&A. So before we start with the questions, and while I get a chance to read through them, I'm going to post the link to our feedback form, which I ask you to please complete. It's not a lot of text. It's actually not even required for you to type anything. You can just have a couple of clicks and submit. It really helps us understand what you find valuable, what you would like to see in the future, and also gives some nice feedback for me to make sure that I'm doing things right for you in terms of presenting this information. And I'm just going to open the chat again. And I'm going to add the survey link over here. And I'm just going to have a quick glance through the Q&A section while you complete that form. And we're going to be pausing this webinar. I'm only going to be standing by for a couple of seconds while you complete that form. Let us see. Olive. All right, we have a couple of questions over here. Let's check the chat. I'll scroll down in the front. Okay. All right. So let's start with the first question. Is it possible to have the slides? Yes, of course. You'll get the slides after this event. You will receive a PDF, and you'll be able to read them at your leisure. Let's go with the second question. Ikenna, I hope I am pronouncing your name right. Are replays possible? So there could be two types of answers for this. Is it the replays for the webinar? Yes, they are always available. You'll be able to find them on Facebook and on YouTube after the webinar. If we're talking about replaying specific requests, so as I mentioned, you can retry requests if some are failing, or maybe even reroute them in the future. And that would count as a replay of your HTTP request to a microservice. But in terms of X-ray, it is not possible to like get a trace and do another replay to it. That is something that's not covered by distributed tracing at this moment, or at least not the one from AWS. All right, I'll send this live. All right. Yep. Another question about the recording. Also about the presentation. All right. If there are any other questions, now would be the time. If not, I'll take this opportunity to mention the upcoming webinar in a couple of weeks related to front-end technologies. So basically, we're going to be looking at Node.js in JavaScript and how you can build a modern serverless application using just one language, both for the application and also for the infrastructure. I think that's going to be a pretty interesting topic, especially for the people out there that are starting out with cloud technologies, especially if you're a front-end developer. So if you're interested about that, you'll surely see the invitations in the future in your inbox. And if you have any other ideas or any other challenges that you face currently that you would like to find out ideas, solutions, services that can help you out, please do leave that in the feedback form and we'll make sure to create either a blog post or a webinar for you. Thank you very much for joining me tonight on our webinar over here. I wish you a wonderful evening and a very nice day. Cheers.